Hi students, this is Somesh Rao. Now we are discussing the CUT model exam. Okay, let's go to the paper discussion. Cyclohexane carbaldehyde. Cyclohexane carbaldehyde. Cyclohexyl carbaldehyde is reduced with zinc amalgam and KOH. That is called Clemmensen reduction. Due to Clemmensen reduction, carbonyl group present in aldehydes and ketones reduced to methylene group. Methylene. Okay. So here this carbonyl group changes to methylene. This is the answer. Now here, what are the limitations? R C double bond. This is aldehyde or ketone. Then we go to the Clemmensen reduction. Zinc amalgam and concentrated HCl. Then carbonyl group changes to methylene group. What are the limitation for this one? Limitation: acid sensitive groups. Limitation. This reagent is not suitable for acid sensitive groups like double bond, triple bond, OH and ethers. These are the limitations. Next, one more reagent is there, that is a Wolff-Kishner reduction. That is hydrazine, glycolic KOH and heat. So this also same. Carbonyl group in aldehydes and ketones reduced to methylene. What are the limitations? Limitations are: is not applicable for halogen compounds. Next, esters, acid chlorides. Okay, na? These are the limitations. So, aldehyde is reduced with Clemmensen, we get methane. This group changes to, okay, clear? The next one. Second one, an organic compound formula is C3H6O. It may be, that is a CnH2nO. It may be aldehydes or ketones. It may be enol forms or ethers also possible here, main. And then this is a negative test for negative. Negative test means it is the positive. Silver mirror test. This is a negative silver mirror test. So compound is aldehyde. Sorry, compound is ketone. Does not. Next one is, it reacts with oxime. It may be carbonyl compound. So 3 carbons and ketone. 3 carbon ketone is, this is the answer. Clear? Next one is Stephen's reduction. Which of the following group converted into? What is the Stephen reduction? Then alkyl cyanides to aldehydes. Here what is the reaction? partial reduction with stannous chloride and followed by hydrolysis. Okay, na? Now here we go to R C triple bond N is treated with SnCl2 HCl, get 2 hydrogens. Then this is RCH double bond NH. These are the imines. Okay. Now these are subjected to hydrolysis. Then due to hydrolysis, here hydrogen OH. So byproduct is ammonia. This is okay, na? Same type of product is given by the diol H also. Okay. So what is the Stephen reduction? Partial reduction followed by hydrolysis. In this, cyanides changes to aldehydes. So answer is this one. Okay. Next one. Acetone is treated with excess of ethanol in the presence of hydrochloric acid. We know aldehydes reduced or reacts with 1 mole of acid, 1 mole of alcohol. In the presence of dry HCl, it gives hemiacetal. At the same time, 2 moles are there. 2 moles of alcohols, HCl, lower alcohols, gives acetal. Similarly, ketones, this is hemiketal. Next 2 moles, this is ketals. Clear? Now this is excess means 2 moles. Okay. Now this is acetone, CH3, C double bond, CH3. Then ethanol, C2, H5, this is OH. Then CH2, CH3, OH. Similarly, this one. Now, this is removed in the presence of HCl, CH3, C, CH3, O, C2H5, this is C2H5. This compound is acetals. Clear? So answer is this one. Okay. 1 mole of alcohol reacts with aldehydes to form hemiacetals. 2 moles is, that is a acetal. Clear? Next one. Cannizzaro reaction does not given by. Then generally aldehydes without alpha is a general case. Without alpha hydrogen involved in Cannizzaro reaction is a general. So this is okay, positive, this is a positive, this is a positive, this is a negative. Answer is 2. Here important is not important. Then CCl3CHO is aldehyde. Without alpha hydrogen, it does not give Cannizzaro reaction because it forms halo form. It gives CHCl3. Chloroform will formed with base. That is okay. No? Is a negative test. Is a negative. Similarly, CH3 hydrogen CHO. Here alpha hydrogen is there. Alpha hydrogen is available. This also, it gives the positive test. It gives the positive test. This is a negative test because it is a steric endurance. Due to steric endurance, this alpha hydrogen is not participating in the reaction. So these two are limitations. Generally, aldehydes without alpha hydrogen involved in Cannizzaro reaction. But limitations are, here there is no alpha hydrogen, but it does not involve in Cannizzaro. Here alpha hydrogen is there, but it gives the positive test. These two are important. Clear? Next one. Aldehyde with, this is a crossed aldol reaction. This is C6 H5 CHO. It acts as electrophile. Then CH3 CHO. It acts as nucleophile. Is treated with base and heated. These two alpha hydrogens are removed minus H2O to form cinemaldehyde. This is cinemaldehyde. This is a cross. Especially this reaction is name is Claisen-Smith reaction. Claisen-Smith reaction. This is a crossed aldol. Especially this reaction is, name of the reaction is Claisen-Smith reaction. Clear? Next one. The reagent is used for acetaldehyde and acetophenone. Generally, this is sodium bisulfite. What is the use of this one? All aldehydes reacts with sodium bisulfite. It gives white crystalline precipitate. White crystalline precipitate. What is that? R C is a double bond O H, then NaHSO3 R CO minus Na plus. Here hydrogen is a OSO2H and then involved in this is COH, then that is OSO2Na is a white crystal. But here coming to the ketones, here ketones, this is all aldehydes, but here limitation is there. Only aliphatic methyl ketones can only form white PPT with sodium bisulfite. Then R C double bond O CH3. One side is methyl, one side compulsory aliphatic, but not is aromatic. Here you go to that, acetophenone is nothing but CH3. Here okay, but is not valid. That's why aldehydes and acetophenone can be distinguished by using sodium bisulfite. All aldehydes gives positive test, but here only aliphatic methyl ketones can only form. Clear? Next one. Propanoic acid is treated with any carboxylic acid, not propanoic acid, CH3, CH2, COOH treated with sodium bicarbonate. It gives CH3, CH2, COONA plus CO2 plus H2O. So this CO2 is available from this one. This CO2 is available from this. So from the bicarbonate group. Clear? Next one is converted into here. Alcohol group is converted into carboxylic acid. Here how many carbons are there? 2 carbons are only there. Here how many carbons are there? 3. Ascending. Ascending means required cyanide. Okay. So first we take pH CH2 CH2OH is treated with bromine or chlorine in the presence of phosphorus or SOCl2 PBr3. Then we get 3 moles are participate. POH taken thrice, that is a phosphorus acid. Okay, this is a byproduct. The next one is pH CH2 CH2 here Br. Then is treated with what is that? KCN minus KBr. Remaining is that is a cyanide. Is subjected to hydrolysis. pH CH2 CH2 COOH. Okay na? Generally for ascending of carbon, we are thinking about the cyanide. So here cyanide is there. This is okay, but this is a hydrogen reduction. So answer is this one. Clear? Next one is a very common question. Alkyl benzene. It contains then at least one benzylic hydrogen. Irrespective of nature of or length of alkyl group. Then this is treated with KMnO4. We get benzoic acid irrespective. Then here how many are there? Here 2 hydrogens. That's why this is the product. Okay. Next one is general formula of aliphatic saturated amines. What is the general formula? Or amine, primary amine, secondary, tertiary, that is any kind of amine. Then this is CnH2n plus 1 NH2, that is. So this is CnH2n plus 3n. So option is this one. Clear? Next one, IUPAC name of, here this is 1 and 2. So N-methyl ethanamine, N-methyl ethanamine. Okay. Next one, which of the following is weakest Brown-Seed base? And then here, what is the basic order? Order of basic nature of nitrogen compounds. That is, one is guanidine is the strongest base. Here, simply to remove this one, this is a urea. Now this is a NH is there, that is called guanidine. Is a strongest base. Next one is aliphatic amines. Okay, na? Aliphatic, again here different categories are there. 1 degree amines, 2 degree and 3 degree. Again in this one, this is alkyl methyl. So methyl amines. For this one, 2 degree greater than, 1 degree greater than, 3 degree. Other than, that means ethyl or other. 2 degree greater than, 3 degree greater than, 1 degree. Okay. This is a aliphatic. The next one, you go to the ammonia. Next one is aromatic. Amines. Next one is amides. Next one is cyanides. Okay, na? This is important. You can make a note here. Which is the least basic? Is a direct bit. This is aliphatic. This is aromatic. So what is the answer? This is the answer. In this, what is the more basic order he asked? At that time, 2 greater than. The next one, this is aliphatic, is a secondary. Okay. Then this is 3, 4 and 1. If you ask the comparison, this is the least, this is the strongest. Clear? Next one. Benzaldehyde can be prepared by the hydrolysis of. Then we go to benzal, Cl and Cl is treated with aqueous KOH. OH and OH is unstable. From this one, water is removed, minus H2O, we get benzaldehyde. Clear? This is benzyl chloride. Clear? Next one. The order of reactivity of following compounds with the Grignard reagent. What is the Grignard reagent here? This is the nucleophile. Aldehydes and ketones involved in nucleophilic addition reactions. Nucleophilic addition reaction. That is a NAR. Nucleophilic addition reactions. Clear? Now, in this, what is a more active nucleophile? Reactivity order of, these are the electrophiles. That's why it's react with the nucleophile. Then reactivity order is reactivity order 1. Formaldehyde, the most reactive. Then next one is aldehydes. Next one is benzaldehyde. Next one is then okay, no? These are, because benzene ring is somewhat releasing character also there, okay, based on the conditions. Benzene ring is available, is able to accept and able to donate. For suppose here OH group is there, is accepted. Here NO2 group is there, this is going to there. That's why it depends upon the conditions. So, okay. So, what is the order? This is aldehyde, this is a ketone, this is a ketone. So, second greater than, third greater than 1. So, what is the answer? 2, 3, this is option. Clear? Next one. CH3 C double bond CH3. That means that is a acetone. Reacts with HCN or NaCN. After that, this is treated with HCl, indirectly HCl. CH3 COH CH3, here CN. This is cyanohydrins. And then this is subjected to hydrolysis. Cyanide group changes to CH3, COH, CH3, COOH. Cyanide changes to carboxylic acid. So, what is the answer? CH3 taken twice, COH, CN, and what is the answer? This is the answer. Clear? This is the A and this is the B. Clear? The next one. Benzaldehyde reacts with methylamine. Important. Then benzaldehyde reacts with methylamine in the presence of acidic medium to form compounds. These are called Schiff's bases. General categories: Schiff's bases. What is the use of this one? These are used as antioxidant. Used as antioxidant in rubber industries. Rubber products. Industries. Okay, no? Rubber products. What is the best ship's base? Important. Best. Ship's base means general. Acid plus base gives rise to salt plus water. NaCl is one of the salt. Salt of strong acid and strong base. That's why salt is one category of family. We go to sugars. Glucose, fructose, then sucrose, all are sugar family. Like that here also this family is ship's base. What is the ship's base? Aldehydes or ketones reacts with the primary amines. Either aliphatic or aromatic, you get one category of product. That product is called ship's base. So what's the ship's base? Then this is aromatic. Aldehyde or ketone. Ketone, that is aromatic. Then primary amines, this also aromatic. Aromatic is the best. That means benzaldehyde reacts with aniline. We get this is the best one, best ship's base. Okay, so what is the answer for this one? This is the answer. Clear? Next one, same Clemmensen reduction. What is the Clemmensen reduction? Then aldehyde group changes to methylene group. So this group changes to CH3. Okay. What is the option? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Option is this one. Okay. Next one. Acetyl chloride reduced with reduced in the presence of barium sulfate and palladium. What is the Rosenman reduction? Special preparation of aldehydes. Rosenman's reduction. What is that? RC double bond Cl acid chlorides is treated with H2 in the presence of palladium, barium sulfate and quinoline. That is R 2 hydrogens, that is C double bond H aldehydes plus HCl. You remember one more reaction. What is that? Here CH3 CH triple bond CH3 and then this is called Lindlar's reduction. You get cisalkins So reagent only same, but reactants are different. Is acid chloride, that is a Rosenman reduction. This is alkyne, this is called Lindlar's reduction. Okay, so here answer is aldehydes. This is a 2 carbon. Okay, no? Next one. Which of the following carboxylic acid highly insoluble in water? Insoluble. Generally, carboxylic acids, lower carboxylic acid. Then C1 to C4, formic acid to benzoic acid, then completely miscible in water. Completely miscible in miscible in water. That means after that, what is the reason? Due to intermolecular hydrogen bonding with water. But here RCOOH, then here and then this size increases, then number of carbon chain increases, hydrophobic interactions increases, solubility decreases. Then size of alkyl groups increases, solubility decreases. So what is the more number of carbon? This is answer is this one. Clear? First three are completely soluble in water due to intermolecular hydrogen bonding. Compared to alcohol, these are highly soluble because compared to alcohol, carboxylic acids are able to form strong hydrogen bonds with water. Clear? The next one. Which of the following is the correct order related to the acidic strength? Then acidic strength Ka is directly proportional to electron withdrawing groups. That means directly proportional to electronegativity. Therefore, fluorine greater than, chlorine greater than, bromine greater than iodine. Same acid has different halogens. So what is the answer for this one? This is the answer. Clear? Next one. Acetic acid reacts with PCl5. CH3, C double bond OH reacts with PCl5, then minus POCl3 plus HCl, remaining is acid chloride. C double bond Cl reacts with benzene in the presence of AlCl3 is a Friedel-Crafts reaction. Friedel-Crafts acetylation. So what is the product? Acetophenone. C double bond CH3. This is a acetophenone. Sorry, acetyl benzene. Acetyl benzene. Then is it treated with the Grignard reagent. CH3 or C2H5 MgBr. Then hydrolysis. Get tertiary alcohols. COH, here CH3, here C2H5. And that is, what is the answer? C6H5OH, this is the answer. Okay. Next one. HVZ reaction. Carboxylic acids are halogenated at alpha position by using then halogen or chlorine or bromine in the presence of red phosphorus. So alpha, this is the answer. Okay, no? Next one. Same. This is, what is that? Wolff-Kishner reduction. Wolff-Kishner. Hydrogen and glycolic KOH. So first one is CH3, CH2, COOH. That means C double bond OH. It's treated with PCl3. Then minus POH3PO3. Remaining is CH3, CH2, C double bond Cl. This is A. And then is treated with benzene. Frederick reaction. We get N pro C double bond CH2 CH3. Then ethyl phenyl ketone. Next one is, this is NH2, then glycolic KOH and heat. So this group changes to methylene group. Okay, na? So answer is this one. Clear? Rosenman reduction. Statement: carboxylic acid do not undergoes Frederick-Trapp reaction. So here Frederick-Trapp reaction belongs to electrophilic substitution reaction. Electrophilic substitution reaction. Electrophilic substitution reaction. That is the IISER reaction. Then, but here carboxylic group, what is required for IISER reaction? Electron releasing groups are favorable. Electron releasing groups are favorable. Okay, this is a carboxylic acid is a strong deactivating group. COOH is a electron withdrawing group. So this is not possible. So this is a correct answer. This is a correct answer. Next one, carboxylic group is meta-orienting group. Is okay. This also correct. So this is not a correct explanation for the statement 1. So answer is 2. Clear? Next one. Same. Acidic character is directly proportional to Ka is directly proportional to electron withdrawing groups. Now this is electron releasing group. This is electron releasing group. This is electron withdrawing group is near. This is electron withdrawing group far. That's why 2 greater than 3 greater than is a 1. Then carboxylic acid 2 greater than 3 greater than 1. Okay, na? Next one. Which of the following is not a primary amines? Then butylamine. What is the butylamine? CH3 NH2. What is the primary amine? Nitrogen has 2 hydrogens are there, that is a primary amine. Okay, is a secondary butyl. This is a CH3, CH2, CH3. This is NH2. Isobutyl CH3, then dimethyl NH CH3 CH3. So what is the correct answer for this one? Then is not. So answer is this one. Clear? Which of the following reagent is most effectively bringing about the following reagent? Listen. Here what you observed? Here carbon is there. Here carbon is not there. That is the same. Sorry. RCH2 or C double bond O NH2. Same number of carbons. Number of carbons decreases, that is called Hofmann degradation. So here you have to check anywhere amide 2 primary amines, you check properly. One is R C double bond NH2. One is R CH2NH2. This is a reduction. Then here RNH2 is a -1 descending. This is Hofmann bromamide degradation reaction. That is a very important concept. Clear? In this one, same number of carbons are there. Is a reduction. What are the most effective reagent? Answer is this one. Okay, I give the table. Make a note. 1. What is the use of LiAlH4 and followed by hydrolysis? Okay, na? One. Aldehydes changes to primary alcohol. Then ketones changes to secondary alcohol. Okay, I give the answer. Don't thinking about them. I give the total concept of the reduction. Next one, acid family. Carboxylic acid, COOH. It gives primary alcohols. Then acid and derivatives, RC double bond Cl. Then what is the primary alcohol means? RCH2OH, same number of carbons. Then this also same, primary alcohols. The next one is RC double bond OR dash. It gives the alcohols 2 moles, primary alcohols. Then RCH2OH plus R dash OH, 2 moles. Next one is anhydrates, RC double bond then we go to this is anhydrate, you get a primary alcohols. Next one is here also 2 moles, is a 2 moles, here also 2 moles. Next one is amides. It gives primary amines. That is RCH2NH2. Next one is RCN, cyanides. Cyanide changes to primary amines. Then R isocyanides. Then it gives the secondary amines. One side compulsory methyl. Next one aliphatic. Then RNO2. This is aliphatic. It gives primary amines. Okay, na? Then it does not affect on any other. This is 1. Okay, na? This is LiAlH4. Next one is, okay, note this point. Next one. Second one. NaBH4 and followed by hydrolysis. Only 3. One is aldehydes changes to primary alcohols. The next one is ketones changes to secondary alcohols. Next one is acid chlorides changes to primary alcohols. Then this is NaBH4. Next one. Here we go to sodium ethyl alcohol. Sodium ethyl alcohol. This is called Bavalt-Blank reagent. Blank reagent. And then here one, 2, 3, 4 RC double bond OR dash changes to primary alcohols. This is and cyanides changes to primary amines. Primary amines. Then RNC changes to secondary amines. Generally, this is called Mendes reduction. Mendes reduction. Okay, no? This is. Next one is. This is a Bavalt-Blank, NaBH4. Next one is. Next one. Here. BH3 THF and CH3 COOH. This is HBr, hydroboration reduction. This is 1. Second one, third one is carboxylic acid to alcohols, 1 degree alcohols. Next, fourth one is ester to primary alcohol. But here important point is carboxylic acid is better than esters. Esters. Okay, no? For lithium aluminum hydride is a reverse. Okay. These are the very useful point for competitive level. Okay, na? Okay. Properly we can practice. For our question, what is the answer for this one? This is. Okay. Next one. The most convenient method for, then here he mentioned the 1 carbon less, that is called Hofmann degradation. RC double bond NH2 treated with Br2 in the presence of base, we get a primary amines. That is okay. Next one. So what is the answer for this one? Third one. Next 30. Which of the following pathways is converted into? Then here, what you observed? Here how many carbons are there? 1, 2, 3. Here how many carbons are there? Carbons, 3 carbons. Here 2 carbons. Obviously, what is that? Hofmann degradation. What is the Hofmann degradation? This one or this one. 2 possibilities. So first one is CH3, CH2, C double bond OH treated with SOCl2 minus SO2 minus HCl changes to acid chloride, C double bond, here Cl. This is treated with ammonia minus HCl, CH3, CH2, C double bond, NH2 is a amide. This is treated with Br2 in the presence of OH, Hofmann bromamide degradation reaction. We get one carbon less, CH3, CH2, NH2. So what is the option for this one? This is clear. Okay. Next one. Previously I explained what is the boiling point. One more important point. Boiling point depends on not only that, entire 4 different points. One is hydrogen bonding. Second one is molecular mass. Next, hydrogen bonding capacity increases, boiling point increases. Molecular mass increases, boiling point increases. Third one is the polarity. Polarity increases, boiling point increases. Next one is surface area. This increases, boiling point increases. That's why here primary means secondary means tertiary. In tertiary there is no active hydrogen. Primary means has 2 active hydrogen. That's hydrogen bonding strength is higher than the secondary and tertiary. So boiling point order is primary amines with same number of carbons greater than secondary amines. Third one is tertiary amines. Clear? Answer is CH 3 degree is the least. This is the answer. Okay, no? Okay. The next one. The most basic. What is that? Previous you discussed it. This is aromatic list. This also aromatic. In these two, this is lone pair not participate in the resonance. Here secondary. 4 greater than, 1 greater than, 3 greater than 2. So most basic is a secondary amines. Previous I gave guanidine, aliphatic, ammonia, aromatic. Okay. Next one. Which of the following amine does not react with the Hinsberg reagent? Here what is the Hinsberg reagent? Benzene sulfonyl chloride. That is benzene sulfonyl chloride. So primary amines gives white precipitate. Secondary amines also able to form white precipitate, but secondary amines white precipitate is not soluble in acid. Okay, na? Here primary RNH2 primary amines reacts with this one. What is the product? pH. That is this hydrogen that is removed. SO2 then NHR. This is the active hydrogen is there. That's why is soluble in NaOH. Then secondary then no active hydrogen, insoluble in NaOH. Tertiary, there is no reaction. So, which of the following does not react with? Primary amines, secondary amines, both are reacts with Hinsberg reagent. Primary amines forms N-alkyl benzene sulfonamide. It has a active hydrogen, is soluble in NaOH. This is insoluble. Here there is no active hydrogen, there is no reaction. This is the answer. Clear? Next. Here primary amines reacts this one to form this is a carbyl amine test. This is a 4. Carbyl amine test. Carbyl amine test. Next one is Hofmann degradation. Then one carbon less, CO, CH3 and H2. This is 1. Hofmann bromamide degradation reaction. Then this is OH group changes to alcohols, is it 2. This is isocyanide reduced with this one, you get a secondary amines, that is a Mendes reduction. 3. What is the option? 4, 1. This is the option. Next one. Then this is diazotization. Then NaNO2 plus HCl. Diazotization. Here amino group changes to benzene diazonium chloride, N2 plus Cl minus. This is the same, NO2. Then is reacts with H3PO2 plus H2O. It gives H3PO3 plus 2 hydrogen. Here compared to this product, in competitive here you ask this point. What is the, this is a byproduct, what is the byproduct Henth factor? So, in this one, 2 hydrogen, out of 2 hydrogen, N2 is removed, next hydrogen Cl, HCl, remaining is, here CH3 is there, here NO2. This is a reduction. H3PO2 plus H2O is used to benzene diazonium chloride. This benzene diazonium chloride is replaced with hydrogen. N2 is removed as N2 gas. This Cl and hydrogen HCl, one more hydrogen is added here. Okay, na? So answer is this one. Next one. Nitrobenzene reduced with tin HCl. What is the P? P is nothing but aniline. P is aniline. Then is treated with nitrous acid. Then diazotization. N2 plus Cl minus. What is that? This is a Q. And then this is treated with next one. HBF4 and heated. And then we get fluorobenzene. F plus N2 plus HCl plus BF3. This is called Bald-Seaman reaction. Bald-Seaman reaction. Okay, na? Conversion of benzene diazonium chloride to fluorobenzene. Okay. Next one. Which of the following is natural polymer? Natural. This is a starch. Clear? Next one. Bakelite. This is a bakelite is a, what is that? Is a cross-linked polymer, is a thermosetting polymer. What is the elastomer, fiber and thermoplastic and thermosetting? What is the elastomer? Elastomer is nothing but those polymers in which polymer chain held together by the weak van der Waals forces. That means weakest intermolecular force of attraction. Intermolecular force of attraction. That type of polymers are called elastomers. What are the category? Rubbers. Rubber. Then bone iron, then vulcanized rubber. That is a vulcanized rubber. Vulcanized rubber. What is the fiber? Fiber means the polymer in which polymer chains held together by strong intermolecular force of attraction. Intermolecular force of attractions. Then here is very strong. What are those? Polyamides. Polyamides. What are the polyamides? Nylon 66. Nylon 66. Then polyesters. Then what is that? Decron, terline. Terline or decron. Then next one is, what is the thermoplastic between them? Then interactions between 1 and 2. I am taking is a 1, this is a 2. What are those? Polythene. Next to PVC, polyvinyl styrene. These are the families. What is this one? Is a cross-linked. That means here very hard is a bakelite and what is that? Urea formaldehyde resins. Urea formaldehyde resin. Okay, na? Here bakelite belongs to this family. Clear? Next one. Which of the following used as a fillers in soap industry? What is the fillers? Those compounds which able to increase lather forming ability. Lather formation ability increases. That type of compounds. What are those? 1. Sodium rosonate, sodium silicates, sodium carbonates. Next one is borax. These are the, okay. So answer is this one. Clear? Next one. Acranyl. What is that? Vinyl cyanide. What is the vinyl cyanide? Acrylonitrile. That is answer. Clear? Next one. Which of the following is used for? Then this is a Aquanyl. Then polyethylene glycols are used in the preparation of which type of detergent? Here this one and stearic acid to form non-ionic detergents. Stearic acid and reacts with polyethylene glycol to form non-ionic detergents. Next one. Which of the following drug is not antihistamine? Okay, this is answered. This also known as Salvarsan. What is the use of this one? This is the antibiotic. Remaining three are antihistamines. This is the first used antibiotic for syphilis. Okay. Next one. What is the copolymers? Copolymers means monomers having different functional groups. So this is only one wrong. This is wrong. This is a nylon 6,6. Nylon 6,6 is nothing but hexamethylene, diamine. Next one is adipic acid. Here this is a 4. Is adipic acid. That's a 6,6 means here 6 carbons, here 6 carbons. Okay, na? Next one. Dettol it consists of that is chloroxylenol plus then this is terpenol. This is chloroxylenol. Then this is the answer. Chloroxylenol and terpenol. Which of the following discussed about? What is the elastomers? Elastomers are weak forces. That is a vulcanized rubbers. That is. Next, fibers, strong. Strong means what is that? This is the esters. Esters, polyesters, polyamides. Thermoplastic, PVC. Thermosetting, bakelite. What is the answer? Yes or yes or this is option. Okay. Next one. Which of the following polymer is prepared from caprolactam? Is a nylon 6. Next one is a Dacron. A Dacron is a polymer of what is the ethylene glycol, and then this also known as terylene. That is a terrycotton. Terephthalic acid. What is the terephthalic acid? Ethylene glycol and terephthalic acid. This is a terephthalic acid. Okay. Next one. The catalyst is used for polymerization of olefins. What is the first one? That is a Ziegler-Natta. Ziegler-Natta catalyst. Ziegler-Natta catalyst. What is the Ziegler-Natta? What is the use? It is used for preparation of high density polythene plastic. Okay, no? This is the answer. Second one is Wilkinson. Wilkinson catalyst. What is the Wilkinson catalyst? RH rhodium PPH3 taken thrice Cl. It is used for hydrogenation of alkenes. Then homogeneous catalysis, that is important. Homogeneous catalysis. Then what is the next one? Third one is palladium catalyst. Palladium, general H2 in the presence of nickel, H in the presence of palladium. This is catalyst. Then this also same, but this is a heterogeneous. Clear? Next one is JEE salt. What is JEE salt? This is the first prepared organometallic compound, KPtCl3 C2H4. This is. And then this is a JEE salt catalyst. What is the use of this one? This is optical resolution of alkenes. Optical resolution of this catalyst is used for optical resolution of alkenes. Clear? And then the artificial sweetener containing chlorine and stable at cooking temperature. This is unstable at cooking temperature, but this is the stable at cooking temperature. So answer is 3. Clear?